In this demonstration, we are going to take a look at method overloads. A method overload is simply any class that contains two methods with the exact same name. So if we had static void test and accepts an int, we have another static void test. This is illegal because one of the rules of overloads is the parameter list must be different. If we change this to a double, now it's legal again. So let's just, in the method, simply print out the value. Clearly, in a real application, it would do something more than simply printing out to the console. But the whole point of overloads is to provide the ability to name a method the same in a class even though the input parameters are different. However, when you do this, you should really limit the use to when the methods essentially do the same thing. It wouldn't make a lot of sense to have this method called test and this does a console write line and then another one that does not do a console write line, because they are not essentially doing the same thing anymore. So how do we use an overload? Well, let's create an int x, set it equal to 10, and a double y, and we'll set that equal to 5.5. Then just to make sure we know which one we are in, I'm going to embellish this code a little bit. When I output it, I will call this one test int, and then we'll print out the x. And so I don't have to type all that again. I'll copy it and change this to double. Now we know when we call test with x or test with y, we can tell which one is which. We'll end with a console read line, just to be sure. Not read line, read line, just to be sure we can see the screen. You can see test int 10, test double 5.5. Would there be a difference if we created another overload, but instead of int x, we specified ref int x? And yes, it's absolutely a different overload and legal because this ref changes the nature of the method and how we would call this particular version of test, because we'll never confuse it with this one here because it requires literally the ref keyword to specify which version of this overload to call. What about some practical examples why you would have overloads? Consider a program that is going to read a file in from the hard drive or some other location. We might have a method, and we'll say it returns a string. We'll call it load. And this one is expecting a path for the parameter. And I'm just going to return string.empty just for the demonstration purpose here. So this will load a file, the contents, into a string and return that string as its result. But we might also want to, instead of passing in a string, we'll pass in a file info object that specifies the file, like we already have a pointer to the file somewhere on the hard drive or on a flash drive, and we're going to pass that in instead of just a path. So they will essentially do the same thing, and I can actually put the real code in here. It's relatively simple. Say file dot read all text, and I supply the path. So it's a nice built-in method of the file class where if you have a valid path, it'll read all the text in from that file and convert it to a string and return it from the method. But if I have a file info, then this will change a little bit. I'll still use the read all text for simplicity, but instead of passing in path, I'm going to find the full name of that file name and then return read all text. There are many different ways I can do this, but the end result is we have two methods that are essentially doing the very same thing. Some people don't like overloads. They would prefer instead to have explicit methods. So I'm going to add two methods in here and show you what they would look like not being an overload. So instead of calling this one load, I might call it load by file name. And this one might be called load by file info. So now I have two distinct method names. It's doing the same thing as the overloads did before, but now instead of all sharing the same name load, the method name describes how it's going to do its work. So it avoids overloads, but still gives you essentially the same functionality. This tends to be a stylistic issue, like many other things in the C# language, as to which approach to take. However, in other technologies like Web API, which is a distributed programming technology for communicating computer to computer using a web protocol, it does not work with overloads. So you will have to use the second technique to supply multiple methods from a single service. So there are cases where overloads just will not work.